Hello everyone, my name is Samatha. I'm a master student in computer science at Kansas State University. Today I'll be walking you through a computer vision challenge where I have trained a data set of flowers using a pre-trained Resnet-50 model. I'll show you how to apply the transfer learning to differentiate among various flower species effectively. We'll begin with a Resnet-50 model that has already learned from the vast array of images, and then we'll adapt it to our dataset and train our dataset. By the end of this walkthrough, you will see just how effective this approach can be when paired with right dataset and tuning. Let's get started. So to begin with, I'm trying to import the necessary libraries like Torch library to work with the tensor and neural network training on GPUs. Then OS for interacting with operating systems like reading the file paths, and then torch.nn. It contains the neural network layers and utilities, and Torch Vision. This provides the tool for image processing, pre-trained models, and datasets. Other important libraries include matplotlib.pyplot, which will be useful in plotting the graphs and visualizing the data, and sklearn.metrics to give us the classification report to evaluate the model's performance. And then NumPy library, which is important for numerical operations on array. And then we want image and image ops from the PIL library to do the image manipulation and image processing. And then in the next step, this line configures the PyTorch to use a GPU if GPU is available. Otherwise, it may default the using of CPU to perform any kind of computations. And then here we are trying to define the sequence of image transformations, including resizing, random horizontal flip, and vertical flip. So we can pre-process the data before setting it to a neural network. And these are the parts of data inputs where we are having a training data set from the flower data set and then test data set from the flower data set. And in the next step, we're trying to load the train data set and apply the predefined image transformation and split it into the train and test, training and validation set. Here I'm trying to have a larger training set and a smaller validation set. And in the next step, I'm trying to have a custom dataset class for which, so this is on the test dataset, for which I'm trying to apply the transformations and return the individual image for processing. And then here I'm creating an instance of custom dataset class for test data and apply the transformations, convert the images into tensors, and then resize them to specific dimensions. And here I'm trying to have a data loader for training, validation, and testing datasets and configure them to process the images in the batch size of 64. And I have kept the shuffle equal to true for training loader and drop last equal to true for all of them. So we can drop the last incomplete batch in the set of consistent batch sizes. And this is just to display the class names with their corresponding indexes. We can see there are 5 different classes of our flower dataset, namely daisy, dandelion, rose, sunflower, and tulip. And next step is just to visualize some sample image from our dataset. So this is just for visualization purpose. And here I'm trying to configure the pre-trained Resnet-50 model for a new task by freezing its existing weights. And then we can do this to prevent them from being updated during training. And we are replacing its final layer to classify the 5 types of the flowers. And then the model is moved to a most suitable processing device, GPU or the CPU, to optimize the training efficiency. And this code initializes the Adam optimizer that is having the learning rate of 0.0001. And then this updates the weights of a new fully connected layer in the Resnet-50 model. And then this is for setting up the cross entropy loss to evaluate the accuracy of models prediction against true labels. This code here is to implement the training and validation loops for the Resnet-50 model across 40 epochs, as you can see here. And then we have training loop over here to update the model weights based on the computed gradients from the loss between the predicted and actual labels, and trying to calculate the training accuracy after each batch and calculating the average training loss per epoch and accuracy. And then this is the validation loop to evaluate the model performance without updating the weights. This provides us insight into how well the model can generalize, and calculating the average validation loss per epoch and accuracy. And here we are trying to print the performance metrics such as loss and accuracy. So you can see here validation accuracy and validation loss are printed for both the training and validation phases. So the validation accuracy is keep on increasing, and the validation loss is kept on decreasing, as you can see here. And the final value for validation accuracy and validation loss are 90.62 and 0.0062 respectively, which is good. And then we are trying to print the classification report, which will display as precision recall and F1 score for all the 5 classes of our flower dataset. And then the accuracy is shown as 0.91. Okay, and as a next step, we are trying to plot our results with the loss plot and the accuracy plot. So in this plot of training and validation loss, you can see that the loss is decreasing over time, which indicates the model's learning effectively. And there is no significant gap between the training and validation curve, suggesting that the model is not overfitting. And then in the next graph, we have training and validation accuracy. It is revealing that the accuracy is increasing over time, and the training accuracy being slightly higher than the validation accuracy. I think that's common. And in the next step, the code is switching to evaluation mode, disabling the gradient calculation, and it iterates over the test images and collects the model's predictions. And those model predictions are converted it into array using the NumPy library, and then those predictions are printed. So you can see the output in the form of the array. This is done to process and evaluate the trained model on the test data set to make the predictions without updating the model's weight. Essentially, this is done to see how well the model performs on an unseen data. In our case, which is a test data. Yeah, that's all I have for today. Thank you so much.